Okay, so page 12 is going to be a little complicated, so make sure you pay attention because I have a time limit on YouTube and I have to get it done. So page 12, you're going to need properties of matter. It's in red. You're going to need both purple pages, volume, and magnetism. You're going to need the yellow page, mass. You're going to need the green page, relative density. And you're going to need this white page, physical and chemical properties. So it was on a 4, but I think it's only one left from there. So pause the video and go grab these 1, 2, 3, 4, 5, 6 ones. When you get back, first thing you're going to do is, I'll let you know. So go pause and get all of those ready and cut out. You're going to need a pen and either a highlighter or something else to like circle and underline with. Okay, you're back. I'm going to put these 5 to the side to start. And you want to take in the middle to the left side of your notebook and put the properties of matter. So here it says, so we're going to talk mostly about the physical properties of matter. Those are properties that can be observed or measured. So if you can see them, you can observe them, you are 6th grader and you can do it, anybody can do it. So in addition to these, there are several other ones, but we're going to focus on these properties. I need this to focus. There we go, that's better. So we're going to look at some of these and we're going to add in a few. So the physical properties of matter can be observed, so we can see them like a magnifying glass. It's a bad magnifying glass. Or measured like a tape measure. Okay, we're going to talk about some of these just in general. We're going to start next with this white piece of paper. So this white piece of paper is eventually going to go in above this guy. So let's just go over this a little bit. So physical and chemical properties. So we're mostly focusing on the physical ones. Chemical is kind of like inside. So physical properties do not change the makeup of a substance, only its appearance. So they're never like going to change what's inside. So these include things like color, smell, boiling point, magnetism. So we already know color and smell is, and we just recently talked about boiling point. Properties that can change the makeup of a substance, those are the chemical ones, so they're like what's going on inside. So we've got radioactivity, that's like if it's dangerous. Can it react with water? Acidity, so like is it an acid? Does it rust? And what it takes to combust. So this one is not going to be too complicated. So what you're going to want to do for this one is if it fits above, mine does not, see, look, it goes over. You want to fold it in half and then in half again. Okay? So then unfold it and see which corner or which quarter is the bottom one, and you want to put glue on that section only. So fold it back up and only put glue on that section, and you're going to glue it in above this guy. Okay? So pause if you need to get caught up at any point in time, but I'm going to speed through this so that we can squeeze it all in. So we're going to go around this and see if we can. We have some of them, we don't have some of the other ones. So what we're going to do next is actually volume. So grab the darker purple one, volume. So we remember that volume is how much space matter takes up. So solids are measured in centimeters cubed. Liquids and gels, powders, are measured in milliliters. So this is centimeters cubed, and this is milliliters. Oh. So So 1 milliliter is equal to 1 centimeter. This is also 1. Okay. So again, this one doesn't have anything else to put on here. This is a graduated cylinder, which is what we would normally use to measure volume, especially of a liquid. So I lied. We're going to write that on here. Graduated, yes. It finished school. Graduated cylinder. Okay, make sure you get that all on there. Pause it if you need to. We're going to, again, fold this one into quarters. And again, you want to put the glue on the one that is on the bottom corner, the bottom left corner. And you're going to get that one glued in about there. So eventually when you take the picture of your page, you're going to open up all of these so that I can see that you did work on them. You can leave them folded for now. Okay, next we're going to talk about mass. That's on the yellow piece of paper. So go ahead and get that one out. Get your marker or your color pencil or your highlighter, whatever you're using. Mass, we remember, is the amount of matter in something. We can use it doing a pan balance, so that's one that has like the little cups, or a triple beam balance. And the unit for that is grams. So bigger than a gram is a kilogram. It's 1,000 grams. And smaller than a gram is a milligram. There are 1,000 milligrams in a gram. So the first thing you're going to do is you're just going to fold it in half like this, and we're going to actually write something on the back. So get your pen or pencil, and you're going to write down this. This is important. All matter has mass. So even if it's just a little bit, like air, it doesn't weigh a lot, but it does have mass. So the more matter you have, the more mass. So once you've gotten that written, we are actually only going to fold this one in half. So on the back, so it opens up like this, you don't want to glue the side you wrote on. You just want to glue it on the side that you didn't write on. We're going to glue it right here, right next to our red one. Okay. The next one, we work our way down, relative density. So it's on the green piece of paper. This one. So get that out. We're going to write on that guy. Relative. So that means like in comparison or related to. Like you have relatives who are kind of your family. They're less than your like closer relatives. So we can determine relative density by observing whether an object sinks. That means it goes down or floats in water. So we often compare density to if something is more or less dense than water. In the example over here, we've got corn syrup on the bottom, which sinks below water, so it must be more dense than water. And the block also sinks to the bottom. It's the most dense, where the ball is floating on top of the water, so it must be less dense. Since we know that the block is more dense than water and the ball is less dense than water, we also know that the ball is less dense than the block. Okay, so we're going to fold this in half, and we're going to write something on the back, and then we're going to do with a couple things. So density is a measure of how many particles or how much matter are packed together in a certain amount of space. And we can calculate density. So you're going to actually take this, you've got it folded like this, and you're going to fold it again into a quarter. And on this one, you're going to write how we calculate density. So density equals mass over volume. So we take the mass and we divide it by volume. So this is kind of like our speed triangle. We can calculate one of these as long as we have the other two. Density, mass, volume. So you are going to, again, you know which corner to glue because you didn't write on it. And we're going to glue that in over here, under where it says relative density. Okay, the last one we're going to work on is magnetism, and then we just have just a little bit to write on our red guy. So magnetism is basically what it says on here. We're not going to have to write pretty much anything else, just underlining. Magnetism. Matter that is attracted to a magnet is magnetic. Matter that is not attracted to a magnet is non-magnetic. Here's some examples of some metals that are magnetic. Iron, nickel, steel, cobalt are all magnetic. These guys are not magnetic. Plastic, not magnetic. Try to put it up to a magnet. Brass, copper, like a penny, and cotton are non-magnetic. We're going to take that and we're going to fold it in half. And fold it in half again. And remember, just try to make sure you get that bottom left corner is what you want glued down. Like this one. Okay. Then we're just going to write a little bit of stuff on here for this one, and this one. So solubility is, can it dissolve in water? So if like salt, you put it in water, eventually it's going to disappear into the water, or seem like it disappears. It's going to dissolve into the water. Electrical conductivity. So that's how much electricity it can carry. And then we've got thermal conductivity, which is very similar to electrical, except for that it's thermal. So this is going to be how much heat can it hold? Okay, when you are done with all of those, make sure that you go back and you pause, because I know I was going super fast. When you want to take your picture, make sure that you take one first, like this, with all of them closed, so I can see the backs. And then the next one I want to see with all of them open, so I can see that you highlighted and you wrote on all of them. Relative density, if you want to leave it half closed so I can see that, that's fine too. But that's what you have to do for page 12. Good luck.